Okay, my friends, here we have a Sub-Zero Model 650. This recently came in. I'm going to tell you the history on this refrigerator. We were there in August. Today is actually Thanksgiving morning, 2023. And my wife's inside getting ready to cook the turkey. I'm here trying to make a video. So the story is we put freon in this refrigerator back in August of this year. And last year we also put some freon in it, but someone replaced the evaporator coil. You can see the little label up here for the refrigerant. But what they did not do, they did not change the dryer. Anyway, here's the process port for the refrigerant on the refrigerator compressor. As you can see, they didn't change the dryer. These are the factory dryers. So what we're going to do here is we're going to take it apart. We're going to check for a leak. Obviously it still has a leak, so I don't know if it's the new coil or maybe there's a leak someplace else, but we're going to go through that process and see if we can find what's going on. All right, so now we have access to the condenser because I have seen leaks on these condenser coils. Usually you'll see some oxidation. I don't see any on here. So we're going to take the shelves out and the evaporator and take this all apart so we can get there, and then we'll pressurize it with nitrogen. I do have a new heat exchanger that I brought here. This is the one that this refrigerator calls for. This heat exchanger, one of my techs says is the same thing. It's got a different part number. It's for a 532 and a 511. This is for a 650. So we're going to open both of these boxes and we're going to see what the difference is between those two heat exchangers. But in the meantime, let's take this thing apart. Now I already cleaned this whole refrigerator up, and I've got videos on how to do that, so there's no sense in repeating that. If you need to see that, you can always check out my other videos. Let's see what's going on here. I want to make sure that, you know what, it doesn't look like that evaporator was replaced, but I could be wrong. Let's get a light. All right, let's see. That's the original evaporator. So I want to say that whoever put this evaporator in, it wasn't us, it was another company. They scammed her and never changed it because the dryer hasn't been changed. I mean, it just doesn't make any sense. Jeez. All right. Well, that's leading me to believe that we're going to have to change this evaporator coil and not the heat exchanger. But I'm still going to check for leaks. So I'm going to get my leak detection equipment, my sniffer and my ultrasound. There's some oxidation that's from here, but if this was replaced, I mean, this is an aluminum evaporator, so there are no signs of this thing ever being replaced. So let's get to work. Okay, since we don't have a high side process, we can't hook up the high side yet. But you can see here, somebody put this process port on here. You can see where it was soldered on, but the dryer wasn't replaced. I'm just reiterating what I said before, and we don't think this evaporator was ever changed yet. Somebody put the sticker on here to indicate that the evaporator was changed. So my feeling is that this person got scammed. Okay? They charged her for an evaporator and never replaced it. And that's the reason why we went back a couple of times and put freon in this over the course of the history on this refrigerator, but we never put this evaporator in there. So anyway, I've got my sniffer out here. I'm going to get this. I'm just going to do a quick search for leaks, and if we don't come up with anything, we'll try the ultrasound, and I think maybe just change the evaporator. I was thinking maybe it was the heat exchanger. That's possible, but after looking at this thing now and seeing what was done or what wasn't done, always check the blast joints first, because that's usually where they leak from. Yeah, it's kind of what I figured. It's going to be really hard. It's got a slow leak. It could be leaking from the high side, so I think we'll have to put some nitrogen. Okay, let's go to the next step. Okay. Let's let that drain out, and then we'll put I guess we'll just put a new filter dryer. We're going to have to change it anyway, so we'll do that next. Okay, we're down to 10 inches in the vacuum here, and that's good enough. We'll close this off. And see how much freon we pulled out of here. Wow. Not a lot of freon. That's a lot. Let's see. This says 7.5 ounces. We got an R22 scale we're using here for the 134A. So we're up at 9. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ounces of gas in there. Wow. That's strange. Okay, now that the system's empty, I'm going to change the filter dryer. We're going to pressurize it with nitrogen and see if we can find any leaks. Otherwise, we'll just do a recharge and maybe check the thermistors. You can also cut this with a tube cutter. Okay, I'm getting some positive pressure out of there. Okay, should have been in the vacuum. Okay, now you take a wire cutter and you use, I can hardly see this, I believe it's the 14 or 16, 14 gauge wire will make a perfect cut in this. Let me see where I am here. I just want to make sure I get the right one, because if you do it right, you don't have to do any other work. It's just going to have, there's a 14, is 12. The third one in from the right is a 16. So just let's see if that's going to work. 1, 2, 3. This scores it enough so you could just break it off like that. And then if you look at it, I don't even need a magnifying glass. I can see that it's a pretty good fit. So just, that's just a matter of reference in case you are not sure, because I bought one of these capillary tube cutters here. It says it makes perfect cuts, but it never does. It squashes the tubing. There should be some way to adjust it, and I tried adjusting this screw here, and it doesn't help. So I just use this one. You can use a 16 gauge or 16 gauge wire slot, or possibly the one after that is an 18. Let's try an 18 just for reference here. We can take the old dryer and we can try an 18. 16, 18, right there. See that? It made a little snap. And you just, beautiful. It's even better. Okay, so just as a matter of reference, you want to use 18 gauge wire slot to cut capillary tube. That's going to save you a lot of headaches in the future. Okay, so now we're going to sweat in a new dryer, and then we're going to pressurize it and check it for leaks. Okay, here's this is the filter dryer that I'm going to use. I bought these online. I'm not crazy about them. They use really thin tubing. They're hard to bend. The Sub-Zero dryers, of course, are the best, but they're also very expensive. So, and I like the dryers that have a reduced size at the tip, so you can just slide the cap tube in there. So now with this, what we're going to have to do is we're going to have to crimp this, and I don't like doing that. It just, to me, is sloppy. Still works, but I mean, I can tell just by using this tubing cutter on how thin this tubing is. Just probably only 40 thousandths wall thickness. And you got to be really careful how you bend these. You bend them too much, they're going to break. I mean, they should have made it at least with the longer tube so you could cut it and put that on the shorter side. But not me. I don't make these things. I just buy them. See, that's hitting there. So you got a little bit more. There you go. So this is 1/4 inch tubing. The discharge line there, that line that's going into the, oh, look how thin that tubing is. Gee. All right, so what we're going to do here is, what we could do is we could take an awl, like something like this, put it in here, and crimp it on each side, because you don't want to put the cap tube in here like that and then wind up filling it with solder. That's not going to work. We can do that. And that reduces the hole. Just make sure you solder on that end. Okay, so let's get some sandpaper and prepare for welding. See, this tubing here, I don't know if you can see it, it's twice as thick as that tubing. You know, there's an old saying, you get what you pay for. And if you're just doing this once, that's different. But if you like us, when we buy these things in bulk, 20, 30, 40 dryers at a time. I actually bought 1,000 dryers once from offshore, and I regretted it because you couldn't bend them. They kinked when you tried to bend them. What the manufacturer will tell you is, okay, well, yeah, but the thinner tubing has better thermal qualities. Sure, it's also cheaper to make. And, when you're working with Sub-Zero, it's not about cheap. It's about quality. All right, so this is going to go on like that. Let's plan it out, how we're going to do this. I'm going to put this on like this. We'll open that up with a 3/16 swaging tool. And we'll put this on like that. We'll bring this around this side. Like so. Okay, so now let's get swage this open a little bit. Get you can almost do this with your hand. Tubing so thin. Okay, now a little brush. Flux. So you want this to go in no further than that, because there's a little screen in here. I think, I don't even know. I never took one of these apart. But so you want to go in about an inch. Then do a little bend so it doesn't go in anymore. Once we weld it, solder it, we can bend it and secure it to this bracket here. Ah, look at this. Air leak. Okay, we'll let that cool down. I just noticed this right here. That's not good. That's an air leak. And that could have been causing a problem with the temperature and the operation of the cooling. It would have been sucking in air, affecting the temperature. Could have been the original problem. Maybe we don't have a leak. Maybe it was just this. Anyway, we'll fix this. And fill this up with some permagum. Okay. The other ones here are good because these are pretty well sealed. Okay. We're going to put the Schrader valve back in there. It's Let's see what we got here. I don't know. That looks pretty good to me. Well, we'll see. Okay. Looks like we got 150 going in. Yep, that's 150. That's what it's set at. All right, that looks good so far. Okay, so we got 150 pounds on PSI on both sides of the system. So now we're going to use the ultrasound and see if we can pick up any leaks. I have a feeling there's not going to be any leaks because of that leak where the unit was leaking and sucking in air. Well, let's see what we can do. You're not going to be able to hear this, but I will. So the proper way to check for this is you're supposed to spray water because that'll make the noise necessary for this ultrasound to pick up. No. I'm not hearing anything. Nope. No leaks. All right, let's let that run. We'll pull it into a deep vacuum, and then we need 7.5 ounces, but I don't trust that sticker because I don't believe this evaporator was ever replaced. Nice try. So 8 ounces. And we have 10 ounces in here because we're using the R22 scale, but we weighed the freon in here with a digital scale, and so we know that 1 ounce of 134A is somewhere around here. So that mark right there, that's 2, 3, 4, 5, 6, 7, 8. So we actually have about an extra 1.5 ounces in here. So we could always charge it up by pressure and superheat and all that, but let's get this vacuum done first. Dry out the system, and then we'll move on from there. Okay, now I don't know if you can see this. Try to get the camera in there, but I can actually see down into the refrigerator compartment. So this thing for some reason popped out. You can see the glue up on top. So we're going to try to push this back in and seal this up, and then we'll weigh the gas in. Okay, I'm going to use a little permagum on here just to keep that from popping out again. Okay, we have pulled down to, well, my gauge is reading 30, but we know it's not 30, but it's pretty damn close. So let's close this off. I also took the liberty of replacing that process port that was on this suction line for this process line for the refrigerator compressor. I just didn't like the way it looked. This is a little neater. So now that we're in a deep vacuum, we're going to weigh in 8 ounces of 134A, and then we're going to test it out. Okay, so I put the shelves and everything back in. These have been shut off, so shut the vacuum pump down. And we got a deep vacuum in there, so we'll charge it up like we said. Okay, so this is ready for a charge, to charge up the system. Let's just verify what we have in here. Put it up against something straight so we can read it. And right now, because I used some of this extra refrigerant to run it through the system when it was in a deep vacuum, so that we would have positive pressure, and when we took off our hoses, we wouldn't have sucked in any air. So I did that already. If you're a technician, you know what I mean. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. We have about 1/2 ounce too much freon in here. So we are going to have to time this or weigh this, or possibly just maybe do a partial charge until we get 8 ounces in there. Okay, so we have purged our line. We opened up our column here, purged our line, and now we're going to weigh this gas in. Now we want to put in 8 ounces. charging column has 8.5 ounces in it. So we have to leave a 1/2 ounce in there. So I'm going to charge it up a little bit at a time. No big deal. No hurry. And then we're going to also purge this line here to the... See, I know I have a little bit, like 1 pound of pressure in the seal system now, so I'm not going to suck in any air. But what I want to do is quickly purge any air out of this hose here before I put the freon in. Okay, got a little bit of purge there. Okay, let's give it a rip. Okay, so freon, we're going to have to turn it on, let the compressor suck in the freon because it's still quite a bit of freon in there. So I'm going to plug it in. Let's do that. Let's plug it in. Okay, it's taking it in. Okay, let's stop it and check how much freon. We only want a 1/2 ounce. We'll let that settle down and see where we're at. Let's settle down. There's still quite a bit of freon in there. So let's let it charge up and we'll come back to it. All right, I want to just check this one thing. The heat exchanger for this model 650 refrigerator, it's supposed to be, I brought it with me just in case I needed it, a 701-5918, but we were out of stock. I mean, I had one here, I didn't know it, but my supplier, my other Sub-Zero supplier, only had these in stock. And I was told that these are the same. 701-5724. Now this says 511 heat exchanger, 550, 511. This is the heat exchanger for the refrigerator compartment. This is a 650 heat exchanger. So let's see if they're the same. Okay. This is the 511, 550. This is the 650 heat exchanger, the original one that goes in this box, in this refrigerator. So we both have 5/16 tubing. What I'm going to do now is measure the length of the capillary tube. So it starts there. Okay, so I measured the suction line length and the cap tube length on both heat exchangers, and there is quite a difference, and that is the reason why Sub-Zero has different part numbers, because it's a different heat exchanger. However, just a quick thought. If the only difference between all these heat exchangers is the length of the cap tube and the length of the suction line, why not just make one heat exchanger and just put the instructions on how long each tube should be? And that would save a hell of a lot of warehouse space, not to mention costs. Anyway, it's not my company. Here's what I came up with. I hope you can see this. The 701-5918 is for this model, 650 here. The cap tube is 64. The length of the cap tube is 64 inches, and the length of the suction line is 84 inches. On the 701-5724, which is set for a 511 and a 550, the cap tube length was 72, and the suction line length was 78. So there's quite a difference in there, and that's the reasoning. Okay, so let's move on to, okay, we are back. I flipped the charging column over so that I could get the vapor in. I'm running at about, it looks like 11 pounds back pressure. That's on my gauge. My equipment could be different on yours. I always keep my gauges calibrated. There's a little calibration screw right there where you can adjust them to 0. Now, as far as this is concerned, I still have about a half an ounce. There's about a half an ounce of refrigerant still in there, which is just exactly where I wanted to be. I wanted to put in 8 ounces. Okay, so we can close this off and consider that this refrigerator fixed. It's back together. I just have to put the cover on it, and then I have to change the door seal, and this door has some issues with scratches. I'm not sure how I'm going to handle that. Alright, so I think that's going to be it for this video. Thanks for watching. Hope you learned something.